This piece of glass is rated to stop a real bullet. But what actually happens the moment it's been hit? Today, we're going inside the science of so-called bulletproof glass. And trust me, it's not what you think. Hey everyone, welcome back to BioInspired Tech. We usually talk about robots and future tech, but protection is a huge part of that future too. Today, we're testing this ballistic glass panel in a fully controlled, professional environment, with safety officers and proper gear. Please don't try anything like this at home or outside a licensed range. This video is for education and science only. First of all, there's no such thing as truly bulletproof glass. The correct term is bullet-resistant glass. This panel is a layered sandwich: hard glass on the outside, flexible plastic layers in the middle, and sometimes more glass inside. Think of it like a high-tech onion. Each layer has a job. The hard glass is there to flatten and break up the bullet. The plastic layer behind it stretches and absorbs the impact, kind of like a trampoline catching a rock. This one is rated to stop handgun rounds. It's about centimeters thick, and it's similar to what you might find in bank counters or security booths. Here's how we're going to test it. We'll start with a standard 9mm round, fired from about X meters away. Then we'll step up the stress and see how many hits this glass can actually take. Before we shoot, make a prediction. Will the bullet go through? Will it just crack? Or will it do something completely different? Pause the video and drop your guess in the comments. I'll tell you what I expected versus what really happened right after the test. Remember, this is a controlled test with a trained professional and standard, legal firearm use. Range is hot. Watch this carefully. The bullet hits, and instantly, you see that spiderweb pattern explode across the surface. But look closely, the bullet doesn't punch a clean hole. The glass fractures, but the layers are still holding everything together. Check this out. From the front, we get this beautiful, almost artistic fracture cone. All these tiny cracks are the glass redistributing the energy outward. And here's the really important part, the back side. See this bulge? The glass is still intact here. That flexible inner layer has stretched, caught the bullet fragments, and stopped them from coming through. So from the attacker's side, it looks dramatic and broken. From the protected side, you might just hear a loud impact and see some distortion, but you're still safe behind it. Let's break down the physics in really simple terms. A bullet is just a small object with a lot of kinetic energy, basically, concentrated speed and mass. When it hits normal glass, all that energy is focused on a tiny point. That's why a regular window just shatters and falls apart. In bullet-resistant glass, the first hard layer breaks on purpose. It spreads that energy out into a network of cracks. Then the plastic layer behind it behaves more like skin or muscle. It stretches, absorbs the remaining energy, and holds all those fragments in place. Nature actually uses similar tricks. A woodpecker's skull has spongy bone layers that cushion impact. Turtle shells distribute force across their curved surface. Engineers literally study these biological systems when designing protective materials like this. So this glass isn't just thick. It's a carefully engineered, bio-inspired impact system. Now, one hit is impressive. But in the real world, this material has to survive multiple hits, sometimes in almost the same spot. We'll do 2 more controlled shots with the same caliber, aiming near the original impact point. Same safety rules. Don't imitate this. With each hit, you see the fracture network getting denser. The glass layers are taking more and more damage, and the polymer in the middle is working overtime to keep everything together. By the 3rd hit, look here, the front is almost completely whitened with fractures. And on the back, we're starting to see deeper bulging and tiny flakes. That's the material reaching its limit. And that's why in real security setups, these panels are rated not just for what caliber they can stop, but how many times they can be hit before they fail. You've probably seen this tech without realizing it. Bank counters, some government buildings, armored vehicles, All of them use some version of this layered design. In military vehicles, they stacked multiple layers of glass and polycarbonate, sometimes several inches thick. The goal isn't to make something unbreakable forever, it's to buy enough time and protection for the people inside. And engineers are constantly upgrading this. Newer transparent armors mix ceramics, advanced polymers, and even nanomaterials, all inspired by things like shells, beetles, and bone structure in nature. So even though this looks like just glass, it's actually a really cool example of bio-inspired, high-tech engineering. At this point, our panel has done its job. It stopped multiple rounds, stayed in one piece on the protected side, and showed us exactly why bullet-resistant is a much better term than bulletproof. From the attack side, it looks completely destroyed. From the safe side, it still did what it was designed to do: keep people alive long enough to escape or respond. For me, that's the fascinating part. It's not about the weapon, it's about the engineering and the human lives this kind of tech protects. If you enjoyed seeing the science behind this, I'm planning another episode on how armored vehicles and riot shields are engineered to stop modern threats. So if you want more future tech and bio-inspired protection systems, hit subscribe and turn on notifications. And tell me in the comments, what should we test next? Riot shields, body armor, or even transparent metal? Thanks for watching BioInspired Tech, and I'll see you in the next one.